today. Almost an entire chapter. Okay, where we left off was at question 6.38. So let's take a look at what's going on here step by step. You notice that this one starts up here and then it goes in this direction. It goes down like this to the final product like that. So let's start at the top. And let's see, we're taking this aldehyde and we're adding a proton to it over here to make this oxonium in the first step. So what's happening? Could anybody identify this first step? Would this be a proton transfer, nucleophilic attack, loss of leaving group, or a carbocation rearrangement? Yeah, absolutely. My students are saying proton transfer. I agree with you all 100%. You're all absolutely correct. Right, we're transferring a proton from here to here. So where's the bond that we're making? We're making this bond here. And we're taking a proton from our acid, our hydronium. So we're going to start on one of the lone pairs over here, and we're going to draw an arrow that's going to end up on a hydrogen atom like this. But then what happens to this pair of electrons? Where are they going to go? That pair of electrons are going to have to go onto the oxygen to make a water molecule. So this would be a proton transfer in the first step, and we produce an oxonium. Now, what the heck is going on in this step? Wow, this is pretty neat. We're doing something really cool here. We're making this bond here. But you see that this bond is between this carbon, okay, we're making a bond there, and the oxygen in the water molecule. So we're going to start with our pair of electrons, or start the tail of our arrow on the pair of electrons of the water molecule. We're going to end up over on this yellow carbon here, but we know that that carbon cannot have 5 bonds. That's impossible. And so we're going to break the pi bond and we're going to put the lone pair on the oxygen so that we end up with 2 lone pairs on our oxygen. So how would you categorize this sequence? Proton transfer, loss of leaving group, nucleophilic attack, or carbocation rearrangement? Any thoughts about this one? Yes, absolutely. This would be a nucleophilic attack. Absolutely, a beautiful nucleophilic attack. This is my nucleophile here. This is my electrophile over here. All right, next step. It's kind of vertical, going from here to here. And in the next step, all that's happening is we're removing this proton so that we just end up with 1 hydrogen attached to the oxygen. Well, who's going to take that proton? It's going to be the water molecule, right? Because we know that we started out with acid, then we end up forming water, and so now we're going to regenerate our acid when the water molecule is going to grab one of these protons. And you could draw the curved arrow to this proton, you could draw it to this proton, it doesn't matter. And now, since the oxygen needs 2 lone pairs, we're going to take this bond and we're going to break it, and we're going to put one of the lone pairs on there. And so this is another proton transfer. The next step is where we add a proton on this oxygen over here. We're going in this direction now. And so this is the same thing we drew at the very beginning. We're going to start on our lone pair, and we're going to grab an electron from our acid, and then we're going to reform water like this, and this is another proton transfer. And then in the second to last step, we make this ring. So this one's kind of complex, but what we're forming is this bond right here. That's the bond that's being formed when a pair of electrons from one of these hydroxyls, it could be this one, this one, this one, this one, it doesn't matter where it starts, but they're all equivalent. We form a bond like this. And of course, a carbon can't have 5 bonds, and so we have to break this bond. Now count the number of atoms in the ring. Look, we have 1, 2, 3, 4, 5, 6. Look here, we have 1, 2, 3, 4, 5, 6. So that you see that the bond is being formed between the oxygen, number 1, the carbon, number 6, to make a 6-membered ring. And so this would be categorized as a nucleophilic attack. The nucleophile and the electrophile, excuse me, are in the same molecule. This is my nucleophile. Carbon is my electrophile. And the last step is going to be a proton transfer. Just erase some of this spinach here. We have a proton on this oxygen. We have an oxonium, and then we don't have it over here. If you want to put the lone pairs in, I recommend it. Like that, there's nothing wrong with it. So now water is going to grab that proton like this. We're going to put the lone pair down here. And there you have it, my friends. That is all the steps. And so this was, a proton transfer. And that's the entire reaction mechanism. Again, something that cannot be learned just by watching me do it. And that is why I want you to try questions at a minimum. Try questions 6.39 and 6.47 before coming to class tomorrow morning. Question 6.50 is kind of challenging, but you could give it a try if you want. And we're going to take a look at these problems tomorrow morning. And this is another reason why you can see it's so handy to have the solutions manual for $15. You have not only just the curved arrows drawn, but the explanations behind the rationale for all of them.